This is 2.7, absolute value equations. Please make sure you have these notes imported from eBackpack. Make sure you do that now. In absolute value equations, when we go to solve these, the steps are similar to solving a regular 1 or 2 step equation with a few slight modifications. The first thing, instead of just isolating the variable on one side of the equation, we isolate the entire absolute value expression on one side of the equation. Nothing else can be on the same side of the equation as the absolute value. So everything within the absolute value bars stays on one side, everything else moves to the other. Once you have the absolute value expression isolated, we're going to split the equation into 2 separate equations. And at this point, we'll be able to drop the absolute value bars. The first equation that we set up should look exactly like the absolute value equation, just without the absolute value bars, and you'll solve that one out. The second equation, this one's a little bit different. You drop the absolute value bars on the one side, and on the other, you are going to negate the other side. Now, all we mean by negate is to change the sign. Once you've dropped the bars and negated the entire other side, you'll solve that one out as well. This will usually result in 2 different answers. Because we have 2 answers, you need to do 2 checks. You do a check for each answer into the original equation. So going back to the very, very starting equation, not the one you isolated. Once both checks check out, you put your answer in set notation. Because these are equalities, right, they're equations, you just list them out in your braces. The next slide, we'll be talking about extraneous roots. And before we talk about extraneous roots, we just want to talk about what a root actually is. All right? A root is just a really fancy word for answer. All right, an extraneous will tell us what happens when both checks do not work out. All right, we end up with these answers that computationally you did correctly. All right, But when you plug them back into the check, we find out that these numbers don't actually work in the problem. So when both checks do not work out, you have what we call an extraneous root. If you think about it, if when you isolated your absolute value, and it was equal on the other side of the equation to a negative number, think about this. Can you have an absolute value of something equal to a negative number? The answer is no. All right? By definition, the absolute value of something is the positive distance from that to 0. So for example, if when you had isolated your absolute value, you had gotten something like this, all right? There is no solution to this equation because the absolute value of x, you can never come up with an x value where the absolute value of it is negative 5. So there is no solution to this. All right, let's take a look at the examples. Our first example, 2 times the absolute value of y plus 1 is equal to 8. Our first step is to isolate our absolute value. The only thing that is preventing our absolute value here from being by itself on the left-hand side of the equation is the 2 out front. Right now we're multiplying the 2 by the absolute value. So what we can do is divide by 2 on both sides of the equal sign. We've now made it the absolute value of y plus 1 equal to 4. All right, we've isolated our absolute value, which means at this point we can split it into 2 equations. And if you look at your first one, the first one said leave it exactly the same, just drop the absolute value bars. So y plus 1 equals 4. The second said drop your absolute value bars, so the left side stays as y plus 1, and negate the other side. So we're going to change the 4 into a negative 4. This is the really important step. If you don't do this, you're not going to get a different answer. All right, so the first thing we do, subtract 1 on both sides. Y equals 3. Subtract 1 on both sides. Y equals negative 5. So we just ended up with our 2 answers here. Y equals 3 and y equals negative 5. 2 answers, 2 checks. And we always go back to the original equation. 2 times the absolute value of y plus 1 is equal to 8. Remember, we're setting up 2 checks here. So we'll plug 3 into the first one. 2 times the absolute value of 3 plus 1 is equal to 8. And treat the absolute value almost like a set of parentheses. So we do what's inside of there first. 3 plus 1 is 4. So 2 times the absolute value of 4 is equal to 8. The absolute value of 4 is 4. So this becomes 2 times 4 is equal to 8. And 8 is equal to 8. And it checks out. On the other side, we're plugging in negative 5. So 2 times the absolute value of negative 5 plus 1 is negative 4, is equal to 8. The absolute value of negative 4 is positive 4. So 2 times 4 is equal to 8, which it does. And again, it checks out. Our final answer here, written as a solution set, is 3 and -5. We just list out our values.